Okay, while I was thinking about it, I thought I might record this. These kinds of problems have become relevant on many of our quizzes, and they're certainly the kinds of things that they probably ask us on the AP exam, so we need to make sure we're competent with these. So I wanted to show you another way to approach a problem where you have a circuit that's fairly complex, maybe not with two batteries, so you're compelled to use Kirchhoff's rules, but one where you could just use equivalent resistance and do it without Kirchhoff's rules. On the quiz, I noticed that most of you were approaching these problems by trying to use Kirchhoff, and that's really unnecessary unless the problem has capacitors and resistors, or unless it has two batteries or multiple batteries. So this one's a lot easier to do another way. So let me show you this problem from another book. Okay, so the problem is find the current and find the voltage across each one of the components of the circuit. So what we're going to do first is what you might guess we'd do first is use parallel and series rules to break the circuit down. So first I think we'll probably look at these guys and say those are in parallel. So let's look at another screen. Okay, so these guys are in series, in parallel, so you're going to go 1 over 600. I can write it down here. So it's going to be 1 over 600 plus 1 over that 400 resistor, and then you're going to take the reciprocal of that. So I like to write it like this for shorthand now. So that's actually equal to this 240 equivalent resistor that they replaced it with. And then you say, okay, now break it down further. Keep breaking it down. So these two are in series. You can add those up, and 240 plus 560 is 800. And then you say, okay, well these two resistors are in parallel again, so we're going to go 1 over 800 plus 1 over this 800, and if we take the reciprocal of that, we get that the total equivalent resistance of this entire circuit is 400 ohms. Okay, so now we have the equivalent resistance of the total circuit, so we could start by now finding the current through the circuit, so through just that equivalent resistor. So use Ohm's law, V equals IR, and you can say, okay, so 12 volts are on this battery in this circuit, so that's going to be how much is across that resistor. So it's going to be I times 400, and you divide, and you get I is 12 divided by 400. What is that? Get my calculator, and it's 0.03 amps. I think just to note, I think the book or any professional source probably wouldn't say 0.03 amps. They might say like 30. That's 30 milliamps, isn't it? Yeah, if you move the decimal place and think about it. Okay, so 30 milliamps of current are through that equivalent resistor, but the original question, if you saw, said figure out way back here what the current and voltage are for each one of those. So now you're going to work your way back up, okay? So we're going to start with that guy that we have and work back up. So we're going to say, oh yeah, if this came from these two being in parallel. So we say, in parallel, what do we know about voltage or current? Oh, we know the voltage is the same. So let's write that down here. Parallel resistors have the same voltage. So if this guy was 12 volts, because there was 12 volts in this circuit, then these guys are both going to have 12 volts as well. You see that right here? And then you can apply Ohm's law across those two values. So this one, when we had it before, was 800, and this one I think also was 800. So you can use V equals IR again, and when you use V equals IR, you're going to get 15 milliamps. Should I show that calculation? You know what, and I want to do it in a different color. So let's use red. This is the way I did it in the quiz keys. So let's say V equals IR. So the voltage we said is still 12 volts across both of these resistors since they were in parallel. That's key. That's what's key. That same rule that we've emphasized again and again. If you have parallel construction, voltage is the same. If you have a series construction, current is the same. That's all we're going to use in this. We're just going to work backwards. Anyway, so 12 equals I times each one of these is going to be the same, right? So 800. So we go 12 divided by 800. And what do we get? I got 0.015, so that's going to be, you can see there, 15 milliamps that they got. Okay, and then you say, okay, take it back apart. So then I think this one was those two in series. So it was a 241 and a 561. So in series, they have the same current. So you want to think about, okay, if they have the same current and this one had 15 milliamps, then the current through both of those is going to be 15 milliamps because it's just going through both of them, right? It's current. So that's the key rule. So now we've got 15 milliamps in this one, 15 milliamps in this one, and 15 milliamps in this one. But then we say, oh yeah, this guy came from both of these two guys. So that guy goes to parallel. So what was the voltage across that? Oh, how did we get the voltage there? So I'll do that in blue. So V equals IR. We said we had this was 15 milliamps or 0.015 amps. The resistance for that first one was 240. And then we get the voltage is 3.6. So can you see where they came up with this 3.6 number? And they're going to do the same thing again over here to get this 8.4 number. So now up here this was 3.6, now both of these have 3.6, and you use Ohm's law again, and guess what? That's how you'll get the 6 milliamps for the top one and the 9 milliamps for the bottom one. And then I think you've got just about all the numbers that you need. So notice, you're just working backwards using these two main rules. For things in series, the current is the same. For things in parallel, the voltage is the same, and just repeatedly using Ohm's law again and again on each step. So that's all there is to a problem like this. You don't have to use Kirchhoff. If you want to, and you can do Kirchhoff proficiently, then I'm fine with that. But this is definitely a problem you need to be able to do, because I'm going to be putting it on quiz after quiz. Okay, hope this was helpful. Bye.